Today we will look at Chapter 10 past paper questions from 2016 to 2024, and the name of the chapter is Redox Reaction. Let's get started. Okay, before starting the questions, we must know the basic concepts related to this chapter, and that is redox reaction. What is redox reaction? It's a reaction in which oxidation and reduction takes place simultaneously. So what is oxidation? So there are three basic definitions for oxidation. The first one is it is a gain of oxygen. So if any element is gaining oxygen, it means it is oxidized. So oxidation is the gain of oxygen, or it is the loss of electrons. And this is the second definition. The loss of electrons is called oxidation. And the third definition is increase in oxidation number. So if any element has an increase in the oxidation number, then it means it is oxidized. What is reduction? Reduction is the opposite of oxidation. It's the loss of oxygen. Of course, if one element is gaining oxygen, then the other one is losing oxygen. So if one is oxidized, the other one will be reduced. So that's why those reactions are called redox reaction, in which one element or compound is oxidized and the other one is reduced. The second definition for reduction is it is the gain of electrons, and the third one is it is decrease in oxidation number. So any element, if there is a decrease in oxidation number of that element, it means it is reduced. Okay. And other important thing you have to know about this chapter is the what are oxidizing agent and what are reducing agents. Oxidizing agents are those elements that are reduced. Okay. Oxidizing agent just work as the opposite. So they are reduced themselves, but they will oxidize the other element. So oxidizing agent cause oxidation itself, they get reduced. Whereas reducing agents are oxidized themselves, but they can cause the reduction of the other element. So these are the main concepts you have to remember. Then you can easily answer the question in the exam. So let's see one by one each question and try to find the right answer for those questions. Okay, the first question, which statement about reactant in redox reaction is correct? Let's see, an oxidizing agent donates electron. Oxidizing agent is the one that will be reduce itself, right? So reduce itself means that will gain the electron. So it means this statement is wrong. An oxidizing agent don't donate the electron. It's the reducing agent donates electron. So option A is wrong. Option B, when one element gains electrons, okay, one element gains electron means if one element is reduced, what will happen? The oxidation number of different element increase. Yes, that's right. Because if one element is reduced, the other one will be oxidized. So if any element is oxidized, its oxidation number, of course, will increase. That's why option B is the right answer over here. Let's see another question. When heated strongly, silicon oxide reacts with carbon. Which term describe what happens to silicon oxide? If you see in this reaction, silicon oxide in the reactant has oxygen, but in the product now, oxygen has been removed. It's the loss of the oxygen, right? So what's happening here? The silicon oxide is actually reduced, right? So which reaction is taking place? It's the reduction. So this is the reduction. Let's see question 4. During the manufacture of sulfuric acid, sulfur dioxide is converted to sulfur trioxide. Which type of reaction is this one? So if you see over here, sulfur dioxide becomes sulfur trioxide. It gains the oxygen, right? Before there were 2 oxygen in the reactant. Now in the product, we had 3 oxygen. So what is this reaction? This is actually oxidation, the gain of oxygen. So option C is the right option. Question 5. Ethanol can be turned into ethanoic acid by passing it over hot copper oxide. What is this type of reaction? Again, if you look at this reaction, copper oxide, if you see here, it has oxygen in the reactant, but in the product, it is getting reduced, right? So now the copper oxide is reduced and our ethanoic acid has been oxidized. It was having only 1 oxygen in the reactant, but now we have 2 oxygen in the product. So this is actually a redox reaction. Option B is the right option. Question 6. Metal M react with steam and produce gas G. Which row identify gas G and the type of the reaction when metal M react with steam? You also have to remember this one, that whenever metals react with the steam, they always produce hydrogen gas, okay? None other than hydrogen gas. So hydrogen gas will be the right option. A or B, both can be right. Now let's see which row identified gas G and the type of the reaction. Of course, this type of the reaction, metals reacting with the steam are always redox reactions. So that's why option A is the right option. Why not neutralization? Because neutralization reactions are those reactions in which acid react with a base. Okay, so metal is not a base here, right? Steam is also not an acid or base here. So that's why this reaction is not a neutralization reaction. Option A is the right option over here. Question 7. Which equation represent a redox reaction? So we have different equations over here and we can see their oxidation number. We can see the gain or loss of the oxygen. But first trick you have to remember for these type of the questions that it will waste your time if you start calculating the oxidation number. So first of all, you have to try to find any reactant in which it is in the form of element, not in the compound form. Okay. So most probably that equation will be a redox reaction if that element change into a compound form. Okay. So see here, we have two different compounds, AgNO3, NaCl, and the reactant. We don't have any element here, no element here. But here, if you see, we have iron as an element form, right? But if you see in the product, the same iron has changed into a compound form. So it means this reaction is actually a redox reaction. So this is the best option we can choose. That option C is the right option over here. Question 8. Which reaction of hydrochloric acid is a redox reaction? So now let's see the same trick we have to apply. We can see which one, in which equation we can find the reactant in the element form. If you see in the option A, we only have the reactant in the element form, that is sodium. But now in the product, it becomes a compound. What does it mean? Before, the oxidation state of sodium was 0. Whenever any element is in its element form, it is having an oxidation number that is 0. But in compound form, it will change its oxidation number according to its valency, right? So sodium needs to lose 1 electron to complete its outermost shell. That's why sodium has +1 charge, right? So here it is +1, but here it is 0. So it means the oxidation state has been changed. So this option is the right option. So this is a redox reaction. Option A is correct. Question 9. Which reaction of hydrochloric acid is a redox reaction? Again, we have to look for the reactants in which we can find an element, not a compound. If you see option D, we can find an element and the same element change into a compound form in the product, right? So option D is the right option for the redox reaction. Question 10. Which change represent an oxidation reaction? Okay, chlorine changes to chlorate ions. What are chlorate ions? Those ions in which chlorine will lose 1 electron. So losing electron is an oxidation, right? So chlorine, when changed to chlorate ions, this is an oxidation reaction. Usually chlorine don't make chlorate ions, it make chloride ions, right? This is reduction. This is also reduction. So option A is the right option over here. Question 11. Which changes represent oxidation? Again, we have 3 definitions related to oxidation and we will see one by one. If you see the first one, these are iodide ions and iodide ions are changed into iodine and we also lose 2 electrons in the product, right? So losing electron is oxidation. So option 1 is right. Second, chromium. If you see the oxidation number was 6, but now in the product it changed to 3. Oxidation is actually increase in oxidation number, but here we can see that there is a reduction in the, or there is a loss in the oxidation number. So option 2 is not right. Let's see for option 3. Iron, its oxidation number is 2, but in the product now its oxidation number is 3. So it means there is an increase in the oxidation number. So option 1 and 3, they both are representing oxidation. So that's why option B is the right option over here. Question 12. Which equation represent a reduction reaction? Now, reduction reaction, we have, remember those 3 definitions. What are those 3 definitions? It's the gain of electron, right? So can you see the gain of electron over here? Only in option A and option C, we can see the gain of electron. So any one option can be right. So if an element or an ion is gaining an electron, of course, this oxidation number will be reduced. But if you see here in the product, the oxidation number has increased. So it means this reaction is not right. Let's see the option C. Fe3 plus, when it gains 1 electron, of course, its oxidation number now decrease, right? So Fe3 will change to Fe2 plus. So this equation is right. So option C is the correct answer. Let's see question 13. Which changes represent reduction? Again, let's see one by one. We have chlorine molecule. And this chlorine molecule, when gains the electron, so gaining electron is reduction and it becomes chloride ion. So option 1 is right. Let's see for manganese. Manganese having 7 oxidation number and in product now it is 2. So reduction is actually decrease in oxidation number. So 2 option is also right. Let's see for option 3. Sulfate, the oxidation number is 4. Now it changed to 6. So it means there is an increase in the oxidation number. So it is not reduction, it is oxidation. So now we are only left with 1 and 2 statements. So 1 and 2 statement is right. That is option A. Question 14. Which equation show the reduction of copper? So if you see over here, the copper reduction, so it should lose oxygen, right? So it's losing oxygen here. Can you see in the option A, it's already losing the oxygen in its product. There is no oxygen. So option A is the right option. These two are just the change in the state. So these are not the reactions. And this one is simple. Copper is actually gaining the oxygen. So this is oxidation, not reduction. So option A is the right option here. Question 15. Silver chloride reacts when it is exposed to light. Which row shows what happens to the silver in this process? Okay, whenever silver chloride is exposed to light, and the product will be silver and the chlorine gas. Okay, so now let's see one by one. First of all, if you see the half equation, how we can show the half equation? If it is showing the metal Ag over here, it is not right. Why? Because silver chloride is our reactant now. So silver is in the form of a compound. So it means it is present in a form of ion here, not in the form of metal. So option A or B cannot be right. So we are just left with option C and D. So Ag, when we'll gain the electron, what will happen? It will become a metal, right? So option C and D both are right. So now we have to show that which type of reaction is this? Is it oxidation or reduction? Of course, the silver is gaining the electron. So gaining electron means this is reduction. So option D is the right option over here. Let's see question 16. Aluminium is extracted from aluminium oxide by electrolysis. The ionic half equation for the reaction at one of the electrode is shown over here. Which row describe the change in the oxidation number of the aluminium and the type of reaction at this electrode? Okay, so if you see over here, we have to first find the change in the oxidation number. What's happening? It's increasing or decreasing. Aluminium has 3+ oxidation state over here, but now it becomes a metal here. It is in the element form. So now the oxidation state in the element form is always 0. So from 3, it becomes 0. So what's happening here? Actually, the oxidation number is decreased. So option A or B can be right. So if there is a decrease in the oxidation number, it means this is a reduction reaction. So you don't have to look over here. Just you should know that decrease means it's a reduction reaction. So option A is the right option over here. Question 17. When magnesium is heated with zinc oxide, a reaction occurs. The equation is shown over here. Which substance is oxidized? So it's simple. In the reactant, if you see which one is oxidizing, magnesium, because magnesium is gaining oxygen over here. So anything that is oxidized or reduced will be from the reactant, not from the product. So your answer should be either magnesium or zinc oxide. Because magnesium is gaining oxygen in the product, so that's why magnesium is the right answer. That is option A. Which row describe what happens to iron ions when they are oxidized? So if they are oxidized, it means they will lose the electrons, right? So they will lose the electrons. C or D can be right. And what will happen to the oxidation number? Of course, when they are oxidized, it means the oxidation number will increase. So they lose the electrons and the oxidation number will increase. So option D is the right option here. Question 19. The equation for a redox reaction is shown which element is reduced. So we have to look at each of the reactant because of course in the reactant we can find the reduction or the oxidation. So because we have 3 different elements or the compounds here. So first of all, to make it simple, you have to first look at the one which is in the element form. If you already have one element in your reactants, you have to look for that one. So chlorine is here in the element form. So first of all, we will look for this one, that what's happening to chlorine. So chlorine oxidation state, because it's in the element form, so its oxidation state will be 0 here. So let's see in the product, what's happening to the oxidation number of the chlorine. Of course, the chlorine, if it is in the compound form, its oxidation number will be same like its group number. So its group number is 7. So it means it needs 1 electron in its outermost shell. So 1 electron means its valency is 1. So the oxidation number will also be -1 here. So 0 and -1. So what's happening here? The oxidation number has been reduced from 0 to -1. What's happening here? The chlorine is actually reduced. So who is reduced here? Of course, chlorine. So we already find, so we don't need to look for these 2 compounds. So chlorine is the right answer over here. Okay, question 20. In which change is chromium oxide reduced? So we have to look for the reduction of chromium oxide. If you look for this one, chromium has only 1 oxygen in the reactant, right? So in the product, it has no oxygen. So it means it is reduced, the loss of oxygen. So option A is the right option over here. We don't have to look for option B, C, and D. It's simple. A is the right answer. Question 21. The reactions shown may occur in the air during a thunderstorm. So these are 3 reactions that are occurring during a thunderstorm. Which row shows what happens to the reactant molecule in each of these reactions? So let's see one by one. N2. If you see N2 and in the product it becomes NO. So it means it gains oxygen. So gaining oxygen is oxidized. So option A or B can be now right. Let's see for the second option, NO. is gaining oxygen and it becomes NO2, right? So it's oxidized again. So again, option A or B can be right. Let's see for the O3 now here. In the reactant, oxygen was in the form of O3, but later in the product, it changed to O2, right? If you see over here, also O2 here, O2 here. So what does it mean? It means O3 has been reduced, the loss of oxygen. So option B is the right option. N2 oxidize, NO oxidize, and O3 is reduced. So option B is correct. Question 22. Sodium ions and oxygen ions combine with chromium ions to form a salt. The salt sodium dichromate has the formula Na2Cr2O7. What is the oxidation state of chromium in this salt? So it's simple. We just have to find the oxidation state of chromium. And remember that whenever there are elements in the compound, the overall charge on a compound is always zero. So the charge on this compound is zero. So if you know oxygen always have an oxidation state of -2. So we have 7 oxygen here. So total will be -14, right? So sodium, we already know it belongs to group 1. So its oxidation state will always be +1. So +1 into 2 because we have 2 sodium here. So it is also +2. So how many positive charges are missing? Of course, 12. So there are 12 positive charges are missing, and this 12 positive is for the chromium, Cr2. But this is for Cr2, this plus 12. So Cr will be how much? The chromium charge will be +6 because 12 divided by 2 will be 6. So please don't get confused between 12 and 6 because 12 is the answer for Cr2. But they are asking for the oxidation state of chromium, just simple chromium, okay? Not the chromium Cr2. So this is the right answer. Which one? C. +6 is the right answer for this question. Let's see question 23. The equation for the reaction of carbon with carbon dioxide is shown here. Which row identifies the carbon atom that is reduced and its change in oxidation number? So we have 2 carbon here. One is in the element form and the other one is in the carbon dioxide form. So if you see in carbon dioxide, it has 2 oxygen. This carbon has 2 oxygen, but in the product now, it has only 1 oxygen. So it means this carbon is actually reduced here, not this one because it gains the oxygen, right? So carbon in the carbon dioxide is actually reduced. So if anything is reduced, of course, the oxidation number will be decreased. So it's simple from here that +4 will change to +2. You can also calculate from here. This is the right answer. So B is the correct answer for this question. Let's see question 24. The equation for the reaction between aluminium and copper oxide is shown. Which statement about the equations are correct? Okay, let's see one by one. The oxidation number of aluminium reactant is +2. Wrong, because in the reactant form, aluminium is in an element form, right? So oxidation number will be 0. The oxidation number of the aluminium in the product is +6. Let's see. Is it +6? O3, of course, is -2. So it will be -6 total. So this one is +6. But this +6 is not for aluminium. This +6 is for Al2. So the aluminium itself have the oxidation number +3, right? So this one is also wrong. Let's see the third option. The oxidation number of the copper in the reactant is +2. Right, because we already know the oxygen has an oxidation state of -2. So copper, of course, it has to balance it in a compound. So it should be +2. So this is right. The oxidation number of a copper product is 0. Of course, yes, because whenever any metal, non-metal is present in the element form, its oxidation state will be 0 or oxidation number will be 0. So third and fourth options are right. So where we can find that is option C. So option C is the right option. Question 25. In a blast furnace, iron oxide is converted to iron and carbon monoxide is converted to carbon dioxide. What happens to each of these reactants? So carbon monoxide, of course, when it changed to carbon dioxide, it is oxidized, right? So this one is oxidized and this one is reduced because it was iron oxide and now it changed to iron. So both iron oxide and carbon monoxide are oxidized, wrong. Both iron oxide and carbon monoxide are reduced, wrong. Iron oxide is oxidized, no, wrong. Right? So we are just left with the option D, that is iron oxide is reduced and carbon monoxide is oxidized. So option D is the right option over here. Question 26. In the blast furnace, iron is formed when iron oxide reacts with carbon monoxide in a redox reaction. Which substance is the oxidizing agent and which substance is the reducing agent? So we already know that iron oxide is actually reduced here. So if anything is reduced, it means it's a oxidizing agent. It will be the opposite one. So who is the oxidizing agent over this reactant. So Fe2O3. So option D is the right option here now. Of course, carbon monoxide is oxidized, so it's actually a reducing agent. So option D is the correct option. Question 27. In which equation is the underlying substance acting as a reducing agent? So reducing agent means it is oxidized itself, right? So if itself it is oxidized, then it will be a reducing agent. Let's see one by one. Carbon monoxide. Carbon monoxide changed to carbon dioxide. So it is actually oxidized, right? So it means it's a reducing agent. We don't need to look for the other options. So of course, option A is the right option here. Question 28. In which reaction is the underlying compound acting as a reducing agent? Again, this should be oxidized itself. So any compound or any element that is oxidized itself, it will be the reducing agent. Let's see for carbon dioxide. Carbon dioxide is actually reduced to carbon monoxide. If it is reduced, it means it's an oxidizing agent. So this option is not right. Let's see the other one. Carbon here. If you see carbon is changed to carbon dioxide, it means it is oxidized. It has gained oxygen. So if it is oxidized, it means it's a reducing agent. So option B is the right option here. Carbon is actually a reducing agent. Question 29. Copper metal donates electron to silver ions. Zinc metal donates electron to copper ions. What is the strongest reducing agent? The reducing agent means it should oxidize itself, right? So if itself, it should be oxidized. It should lose the electrons. So who can lose the electron? Copper ions? Of course not. Why? Because it already have lose the electrons. It is in the ionic form. Only the metals can lose the electron, not the ions. So ions options are not right. Even A or C, these both are wrong. Now we are left with B and D option, copper metal and zinc metal. Both of them are the reducing agents, but we have to find the strongest one. So strongest reducing agent means that will be more reactive, that can oxidize more quickly. So who can oxidize more quickly, copper or zinc? Zinc is more reactive than the copper. So it means zinc will oxidize first compared to the copper one. So option D is the right option. Is the strong reducing agent, zinc. Question 30. Magnesium reacts with copper oxide to give magnesium oxide and copper. Which substance is the oxidizing agent in this reaction? So what are the reactants? Magnesium and copper oxide. They both are reacting with each other. And what will be our product? That is magnesium oxide. So if you see magnesium is changed into magnesium oxide, it means magnesium is gaining the oxygen. Magnesium, if it is gaining the oxygen, it is a actually oxidized, right? So it is not an oxidizing agent, it will be a reducing agent. So if magnesium is a reducing agent, then the what will be the other reactant? Of course, it will be a oxidizing agent. So copper oxide is another reactant that will be acting as a oxidizing agent. So copper oxide is the right option. That is option B. Question 31. Chlorine displaces iodide ions from potassium iodide. What is the oxidizing agent? So anything that will be reduced will be actually our oxidizing agent. So who is reduced here? If you see, chlorine was in having the oxidation state 0, but here now it is -1. So there is a decrease in oxidation number. A decrease in oxidation means it is reduced. So anything that is reduced, it is actually an oxidizing agent. So which option is right? Chlorine, not the chloride ions, because chloride ions are in the product. Only our reactant can be the reducing agents or oxidizing agents. So chlorine is the right option here, option B. Question 32. The equation for a redox reaction is shown here. So we have to fill the gaps here. These two lines, potassium iodide is dash agent. So let's find first about potassium iodide. It's already given in your book that potassium iodide is actually a reducing agent, okay? Even if you don't know or you don't remember that it's a reducing or oxidizing agent, you just have to follow these steps. First of all, you have to find for potassium iodide, what is the charge, or what we can say, what is the oxidation number here? So the oxidation number of K is +1 here. And for iodine, it is -1, right? But here, if you see, the iodine is changed to 0. The oxidation state has changed to 0. So what's happening from -1, it changed to 0. So it means there is an increase in oxidation number. So increase in oxidation number means that potassium iodide is oxidized. Anything that is oxidized is actually a reducing agent. So potassium iodide is a reducing agent here. Why reducing agent? Because iodide ions dash electrons. Iodide ions lose electrons because oxidation is the loss of electrons. So loss of electrons, and it is a reducing agent. So option C can be the right option here. Question 33. Aqueous iron sulfate is added to acidified potassium magnate. The purple color of potassium magnate disappear. It's already given in our book that potassium magnate is actually a strong oxidizing agent. And if it change the color with any other product or any other reactant we are adding in that, then it means that the redox reaction is taking place over there. Okay. So if you see the change, there is a change in the color. It means the redox reaction has taken place. Potassium magnate is already a strong oxidizing agent. So it means aqueous iron sulfate is what? Aqueous iron sulfate will be the opposite one. That means it will be the reducing agent. So reducing agent is the right option for the iron sulfate. Now let's see, for aqueous potassium iodide is added to acidified potassium dichromate. A dark brown solution is formed, which row identifies the role of iron sulfate and the potassium dichromate. Okay. Now let's see for the potassium dichromate. For potassium iodide, we already know it's given in our books that it is a reducing agent. So it means potassium dichromate will be the oxidizing agent, opposite one. So option D is the right option over here. Question 34. The equation for the reaction between zinc and copper oxide is shown. Which row shows the oxidizing agent and the reducing agent? Again, oxidizing agent will be the one that is reduced, and reducing agent is the one that will be oxidized itself, right? So let's see who is oxidized here. Zinc is oxidized here. So it means zinc is the reducing agent. So option B is the right option, because copper oxide, the other reactant, will be the oxidizing agent. Always the oxidizing agent and reducing agents are from the reactants, not from the products. Okay, don't do any mistake related to these questions, that you choose the options from the product. Don't choose your options from the product. Only your reactants can be the right options. Okay, zinc and copper oxides are the oxidizing agents or the reducing agents. So option B is the correct option here. Question 35. Copper oxide reacts with hydrogen. Which row is correct? So we have to find again the oxidizing agent and the reducing agent. If you see, copper oxide is reduced to copper, so it means copper oxide is the actually an oxidizing agent. So copper oxide is the oxidizing agent. Yes. So option B is the right option over here. Question 36. The equation for the reaction of sulfur dioxide with acidified potassium dichromate is shown. What is oxidized and what is the oxidizing agent? Okay. Now let's see what is oxidized. So we have to see one by one, SO2 or Cr2O7. If you see SO2 is here, it is having only 2 oxygen. But in the product, it has now 4 oxygen. So it's simple that it has gained the oxygen. So this one is oxidized, right? So sulfur oxide is actually oxidized here. And what is the oxidizing agent? Of course, we already know it's given in our book that potassium dichromate is actually an oxidizing agent. So it's already given here, oxidizing agent is Cr2O7. So the option A is the right option here. Question 37. The equation for the reaction between iron sulfate and bromine is shown. Which row identifies the oxidizing agent and the reducing agent? So again, oxidizing agent will be the one that is reduced itself, and reducing agent will be the one that is oxidized itself. So who is oxidized? Let's see one by one. First of all, you have to look for the element one. That is the more best option to find the right answer. Okay, so bromine is in the element form here, so its oxidation state is 0. Here it is in a compound form, so now its oxidation state will be according to its group number. It belongs to group 7, so it means it just need 1 electron. So its oxidation state will be -1. All the halogens have an oxidation state of -1. Bromine is a halogen, right? So from 0 to -1 here, what does it mean? It means now that there is a loss in the oxidation number, or there is a decrease in the oxidation number, right? So decrease in oxidation number means it is reduced. So if anything is reduced, it means it's an oxidizing agent, right? So bromine is an oxidizing agent here. So bromine is oxidizing agent. And what is the reducing agent? Of course, FeSO4. Iron sulfate is the reducing agent. So option A is the right option. Let's see question 38. An example of redox reaction is shown. Which statement about the reaction is correct? So if you see zinc, 0 oxidation state, and then it is changed to +2, it means zinc is oxidized, right? So zinc is oxidized. So what does it mean? It means it's a reducing agent, right? And copper is an oxidizing agent. Now let's see each option. Zinc is the oxidizing agent, wrong. Zinc is the reducing agent. Again, wrong. So option C or D can be right. Zinc is the reducing agent or zinc is the reducing agent. Okay, so if it's a reducing agent, it will oxidize itself, right? Itself, it will oxidize, but it will not oxidize copper 2 plus. So that's wrong. Zinc is the reducing agent because it reduces the copper ions into copper. So that's why option D is the right option here. Question 39. The equation for the reaction between zinc and aqueous copper sulfate is shown. Which statement is correct? So first we have to find which one is oxidizing agent and which one is the reducing agent, because they have given the options related to oxidizing and reducing agent. Okay. So zinc, if you see here, zinc, zero oxidation state, but here it is now plus 2, right? Because SO4 is minus 2. So increase in oxidation number. Increase in oxidation number means that zinc is oxidized. So if anything is oxidized itself, it means it's actually a reducing agent. So zinc is our reducing agent, whereas copper sulfate is now our oxidizing agent. So the oxidation state of oxidizing agent has changed from 0 to plus 2. That's wrong, because if you see here, the SO4 was minus 2 here, still it is minus 2 here. And the copper was plus 2 here and it's changed to 0. So plus 2 to 0. So it means this one is wrong. The oxidation state of reducing agent has changed from 0 to plus 2. So this is our reducing agent zinc, and its oxidation state has changed from 0 to plus 2. Yes, so that is correct. So that's why option B is the right option. Okay, let's see question 40. The thermite reaction can be used to produce iron from iron oxide. The equation for the reaction is shown. Which statement about these reactions are correct? Okay, let's see one by one. Aluminium is the oxidizing agent. Let's find the oxidizing and reducing agent first, and then we can see these options. Aluminium is oxidized here. It gains the oxygen. So it means if itself it is oxidized, then it is a reducing agent. And iron oxide is reduced here. It loses the oxygen. So it means it's actually an oxidizing agent. Itself it is reduced, but acting as an oxidizing agent. Aluminium is the oxidizing agent. Wrong. Aluminium is less reactive than iron. Of course, wrong, because aluminium displaces the oxygen from iron, right? So it's displaced the iron here, from the reactant, and it makes the aluminium oxide itself. So it means aluminium is more reactant. Even you can find this answer in the reactivity series related to chapter 14 and 15, that aluminium is more reactive than the iron. So this option is also wrong. Electrons are transferred from aluminium to iron. Yes, this is right, because aluminium is actually oxidized here. So if it's oxidized, it means it loses the electrons. So if it lost the electrons, who will gain those electrons? Of course, the iron. So electrons are transferred from aluminium to iron. The iron in the iron oxide is reduced. Yes, iron in iron oxide is reduced to iron. So that's why this option is also right. So option 3 and 4, where we can find that is in the option D. So option D is the right option. Question 41. Iron chloride solution react with chlorine gas. The equation is shown here. Which statement about the reactions are correct? Let's see one by one. Fe2 ions are reduced to Fe3 plus ions. So this statement is wrong. Why? Because if the oxidation number is increased, it is oxidation, not reduction, right? So this is wrong. They've used the word reduce. It should be oxidized. Second, chlorine acts as a reducing agent. What's happening here? Chlorine is actually reduced itself here. Okay, the oxidation state was 0. Now it is -1. So it is reduced. So it means if itself it is reduced, it's an oxidizing agent. So the second statement is also wrong. Fe2 ions each lose an electron. So Fe2 ions are losing an electron here. If you see, Fe was +2 here, right? And then here it becomes +3 because of chlorine, right? There are 3 chlorines. So what's happening? The oxidation state has increased with 1 + 1. So what does it mean? It means it loses 1 electron. Chlorine molecules are reduced to chloride ions. Yes, that's also right here. It is in the form of chlorine molecule, and now it is changed to a chloride ion here. So that's why option 3 and 4 are right. That is option D. So option D is the correct answer for this question. Question 42. The equation for the redox reaction is shown. Which statements are correct? Let's see one by one. Fe3 is reduced to form Fe2 plus. Yes, it is reduced, right? So that's right. Zinc oxidized the Fe3 ion. Zinc is not oxidizing the Fe3. Is it actually reducing? Zinc is reducing the Fe3 ions into Fe2 plus, because if you see in the reactant, it was 3 plus. Now it becomes 2 plus. So it means there is a decrease in oxidation number, that is reduction, not oxidation. So zinc is not oxidizing the Fe3 ions, it is actually reducing the Fe3 ions. Fe3 is an oxidizing agent. Yes, that's right. Why? Because itself it is reduced. So if anything is reduced itself, it means it's a oxidizing agent. It will work as an opposite. So 1 and 3 statement is right. That is option C. So option C is the correct option for this question. Question 43. Four ionic half equations are shown here. Which statement is correct? So let's see one by one. In equation 1, copper ions are oxidized to copper. Copper ions, they are positive and they become now 0. They went to the oxidation state 0, right? So it means it is reduced, not oxidized. So this is wrong. In equation 2, iodide ions are reduced to iodine. If you see here, iodide ions are actually losing 2 electrons to become iodine. So losing electron means it's oxidized. So this is also wrong. In equation 3, iron 2 ions are oxidized to iron 3 ions. Yes, that's right. Iron 2, it was 2 plus. There is an increase in oxidation number now, and there is a loss of 1 electron. So this is actually oxidation. So option 3 is the right option here. So that is C. So equation 3 is the right answer here. Question 44. The reaction between chlorine and bromide ions in a redox reaction. So what is the change in oxidation state of the reducing agent in this reaction? So first of all, we have to find which one is the reducing agent. So the reducing agent will be the one that is oxidized itself, right? So let's see who is oxidized. Bromide ions are actually oxidized here because if you see, it has negative charge here, but now it has 0, right, in the element form. So it means it is oxidized from -1 to 0. There is an increase in the oxidation number, right? So if this one is oxidized, it means it's a reducing agent. So bromide ions are the reducing agent. So what will be the change in oxidation state? From -1 to 0. So option B is the right option here. Let's see question 45. Chlorine displaced bromine from aqueous potassium bromide. The ionic equation for the reaction is shown here. Which statement about these reactions are correct? Again, chlorine is displacing bromine from the potassium bromide. So chlorine is at itself reduced here, right? You can see from 0 to -1. There is a reduction in the oxidation number. So itself, it is reduced. So what does it mean? It's a oxidizing agent. Chlorine is an oxidizing agent because it oxidized the bromide ions. So bromide ions are not the oxidizing agent. That's wrong. Bromide ions are oxidized. Yes, that's right. Because bromide ions from -1, it changed to 0, right? So from -1, the oxidation number has increased to 0. So bromide ions are oxidized. Yes. As electrons are lost. Yes. Because in oxidation, the electrons are lost. So that's why option B is the right option here. Question 46. The ionic equation for the reaction of aqueous potassium bromide with chlorine gas is shown. Which statement is correct? Again, we have to see one by one. Bromide ions are oxidized. Yes, bromide ions are oxidized here, but by losing electrons because oxidation is the loss of electrons. So this option is wrong. Bromide ions are oxidized by losing electrons. Yes, that's right. Bromide ions are oxidized by losing electrons. So option B is the correct option here. Question 47. The equation for the two reaction of iodide ions are shown. Which statement is correct? Both reactions are redox. Okay, let's see one by one that both reactions are redox or not. So if you see here, iodide ions are in the form of ions and they have the oxidation number -1. Let's see here the oxidation number. The oxidation number of iodide has changed to 0 because it is now in the molecule form. It's not in a compound form. So for -1 to 0, it means this is actually oxidized. So if it is oxidized, this one is going to be reduced. So this is a redox reaction. Let's see reaction 2. Iodide ions are present here, and in the product, again, iodide is present in a form of ion, not in a form of an element or in a molecule. Same is for Ag. Silver is present in the ionic form and same it is also still an ion. There is no change in the oxidation state. Here it was +1, here also +1. This is -1, here it is also -1. Only the aqueous solution has changed into solid. So there is a change in the state, but there is no reaction taking place. That is redox reaction, right? So only reaction 1 is the redox reaction here. So that's why option C is the correct option. Only reaction 1 is a redox reaction. Okay, question 48. Substance J takes part in a redox reaction. In the reaction, J gains electrons. So if J gains electrons, it means J is reduced, right? So J is reduced here. So if J is reduced, it means it's an oxidizing agent. So J is the oxidizing agent. Yes, option A and B can be right. And it is oxidized in the reaction. So oxidizing agent always get reduced in the reaction. So this statement is wrong and option B is the right option. J is the oxidizing agent and it is reduced in the reaction and it will oxidize the other element. Okay. So it will oxidize the other element, but itself it will be reduced in the reaction. So that's why option B is the right option. Let's see question 49. When aqueous iron chloride is added to aqueous potassium iodide, a chemical reaction occurs and iodine is formed. Which statement is correct? So iron chloride FeCl3, because this is 3, right? So FeCl3 when reacting with potassium iodide, it will give you iodine, right? So which statement is correct? Iodide ions are oxidized. Yes, it's -1 here and now it becomes 0. So it is oxidized because they gain electrons in the reaction. Wrong. If they are oxidized, they should lose electrons. So this one is wrong. So iodide ions are oxidized. They lose electron in this reaction. Yes, this option is right. So option B is the correct option. Let's see question 50. Aqueous iron chloride FeCl3 reacts with aqueous potassium iodide. Again, the same reaction. Which statements are correct? So let's see, in the balanced equation, V, W, X, and Y have the same value. Yes, this one is right. Why? Because all of them had the value 1. You can try to balance this equation and you will see that all of them will have 1. So it means they have the same value. Now let's see, for potassium iodide is an oxidizing agent. I already have told you and we practiced so many times, so you must need to remember. You don't have to look for the oxidation number now. You just have to memorize now that potassium iodide is a strong reducing agent. Okay, so this statement is wrong. Even you can find from here, but I will not do it because we have already practiced this one in the previous questions. Let's see the third one. A dark brown solution is produced in the reaction. Yes, that's right. Why a dark brown solution is produced? Because iodine is formed. So iodine always give a brown color in a solution form. So that's why your product solution will be in the brown color because of the presence of iodine. So that's why option 1 and 3 is right. These statements are right. So for that one, option B is the correct option. That is 1 and 3. Let's see question 51. An excess of iron chloride is added to acidified potassium magnate. Which statement are correct? So when iron chloride is added to potassium magnate, iron chloride, because it's a halogen, right? The chlor and a metal. And so what will happen here? Now this will be a redox reaction. So the purple color of the potassium magnate, of course, will disappear whenever a metal and halogen compound, or whatever that is, we can call the halide products, they will react with the potassium magnate. This will be a redox reaction. So the purple color will disappear. That's right. Iron is reduced to iron 3. Okay. Iron, because this is a potassium magnate, is an oxidizing agent. So if it's an oxidizing agent, we already know it from our books. So it means it will be reduced. So if it is reduced, of course, iron chloride is not going to reduce. So that's why this option is wrong. Iron is not going to reduce. It will be oxidized. Even it is clear from here because the oxidation number is increasing. So it is oxidized. Magnate ions are oxidized to manganese ions. Wrong, because potassium magnate is an oxidizing agent. So if it's an oxidizing agent, it will be reduced itself. And you can also see from here, the 7 number has changed to 2. So oxidation number has been reduced. So it is reduction reaction, not oxidation. Potassium magnate 7 is an oxidizing agent. Yes, we already know it from our books. So option 1 and 4 is the right option. That is option B. So option B is the correct option. Let's see question 52. Chlorine gas is bubbled into aqueous potassium iodide. What is the ionic equation for the reaction that takes place? So we have to see that chlorine gas is bubbling to the aqueous potassium iodide. So if you see here, the chlorine gas is added into potassium iodide, right? So now what will happen? Because chlorine is more reactive than the iodine, so it will displace the iodine and it will become itself chloride ion, right? So iodide ions will change into iodine. Okay, you can see here iodine, I2, because iodine is always present in a diatomic form because it's a halogen. So halogens are always present in a diatomic molecule form. So iodine, this one is wrong, right? This one is wrong. Why? Because it's a atomic form, right? So now let's see for chlorine. Chlorine becomes now a chloride ion. So which option can be right? They have a negative charge. Yes, that's right. But chlorine becomes a chloride ion. So the ion should not be in a molecule form. So that's why this option is wrong and option C is the correct option. Okay, that's all for the chapter 10.